have, I think this is a 1970s GM alternator, and it's all pretty standard, I guess. You've got the coils here, which I'm not sure. Are we going to remove those?
No, the coils will stay here.
Those coils will stay, okay. And I suppose in here we've got the voltage regulator and some other hardware. And basically the important thing that we want here is the whole rotor, then this whole assembly that we've got, so that Alex can put in his special magnets and make his generator, his efficient generator. So that's the plan.
Yes, we will remove actually this part.
Okay.
This part.
Additional magnets.
Okay.
Yeah. And we will remove all this part, like brushes. Brushes, we don't need brushes at all. We will remove the brushes, but we will remove all this part, and we will remove all this part. This part we will remove for sure, because that for brushes we don't need brushes, and we don't need the rings too.
How, instead of brushes, how is the electrical connection going to be made?
It will go straight from magnet to coils, and we will use like a to get electricity from that alternator to use.
Okay.
Is it understandable?
What are brushes in this sense?
It's transferring from here. You need a way to transfer the electricity between a moving part and a stationary part. So here you've got a moving part and these contacts here that make, can you see those? That make contact with these brushes here. So they'll be rubbing against this and making an electrical connection. And this is moving, and you can see the bridges that are made there from that.
And I can explain how it works. The electricity from one wire goes there, inside to one brush. Through one brush, electricity then runs through this ring.
Okay.
And it activates inside like electric magnet. Is it right?
Yeah. If you look inside, you see a coil in there. Can you see the coil? That's electromagnet.
It's here. But it's too dark.
Need a light.
Too dark. No, it's later.
Okay.
Later, when I will disassemble that, I will show.
So your plan is to put permanent magnets in here.
We will remove that electric magnet.
Yeah.
With this part, and we will set up 14 permanent magnets.
And what kind of magnets?
It should be grade 52.
Okay. What are they made of?
Size, they do.
What?
They do. That's the strongest grade of what they have right now.
What material? What?
Neodymium ferrum bore.
Okay. Okay.
Mixed, and they plated first layer, but by copper, and second layer by nickel.
Okay.
It's like stamps, not rust.
Okay. And so the idea is that we're going to be making an efficient generator.
It should make more. It should produce more energy. than a regular alternator.
Right. So, in terms of efficiency, what sort of efficiency, if you could give a percentage?
We'll see.
We'll see. Okay. You have an estimate?
We'll see, but it depends what the size of the magnets we will fit inside.
Okay. And what makes it unique? What makes it different from a regular generator?
From regular generator, as a big difference, we will use electric circuit here. I still keep the circuit and the design in secret because it's patentable part.
Okay.
It's very, very, very patentable, and then we will see.
Okay, so you'll put that together, and then eventually I'll see.
Yeah.
I'll see how it works.
Because it's magnetic resonance, and when you shake something, shakes, you can see like it shaking a little bit by itself. It's like inertia. Is it right? Yeah, inertia.
Inertia.
Yeah.
Yeah.
Of electromagnetic waves.
Right.
And we will use this inertia for our purpose.
Okay. So the plan is, we're still recording, right? Okay.
We will make like not twice. It should be 4 times more power than a regular alternator.
So 4 times.
Makes,
okay.
Yeah, more than 4 times. But right now I can say for sure, if we will use cheapest magnets as you can find, like it costs like $35.
Yeah.
$35 Canadian dollars.
And the more expensive ones.
It's 14 magnet, each of them like $1.50. $2. Okay, let's say $2, $28 all set for 14 poles for this alternator.
Okay.
Because this alternator use 14 poles to activate these coils.
Okay.
So it's not big, not very expensive, and we'll see what we can find in that new design.
Yeah.
Probably it will change our world at all to electric. Because gasoline dependence, that's very hard because Canada not so rich really for oil, and we make like alternative project to use electric cars and electric bicycles for our own purpose.